how to implement as a neural network. We can flatten, we can transform this two-dimensional data to one-dimensional data for from 1 to 36, and the filter can be presented as a weight here, and the feature map can be a hidden layer. So we don't need to worry how to select the filter. We can let the neural network to learn the weight, just like we explained in the previous page that the weight will be updated by training. So it is very, very important improvement. We don't need to worry about how to define feature. In traditional vision, computer vision, the feature need to define by human. So it is a very tough task. But if we combine convolution with neural network, it becomes a very easy task. And here we explain the types of the image application with CNN. The first one is image classification, which means give you a picture and please tell me what animal in it. So dog. And second application called object detection, which means that the picture you not only tell me the class of the object, you need to identify the location of that class. So in this case, the dog 1 and the dog 2 has been identified with the bounding box. And the further application called segmentation, it is not just to identify the location of the object, but also the silhouette of the object. So as you see, the top two picture of the original, the person, the sheep, and the dog, the boundary has been identified. It's called segmentation. So these three applications are very important for the real world: image classification, object detection, and segmentation. Here is the example of the CNN. Google has a service called the photo search. So you can use their service to identify the object of your photos. So it is kind of the image classification we just discussed. And this is another example of CNN. It is the Japanese farmer. He used the CNN to select conker bird. The conker bird here, as you see, that have many classes, many types. So they train the models to AI model, deep learning model, to identify which class of the cucumbers. It is long, medium, short, or have the bending. Bending means some bad quality, or even the worst one. So the farmer before they need to identify by their own eyes. But if use the CNN model, they can identify the different combo bird just in seconds. So it is very useful. And this is another example from medical. It is called the diabetic retinopathy is just some eye sick, and the diagnosis based on the fungus photography. Fungus photography means taking a picture of your own eyes. So the CNN models can tell you which one is health, which one is disease, because as you see, there are some spot here. It is some blood comes out. So this is the binary classification, healthy, disease. Or even you can train the model to have more detail of such a diabetic retinopathy. One is no DR, two, three, four, and very serious in five. So this is application in medical image. And we also can use the CNN for defect detection during manufacturing. What is the defect detection? Take this as an example. The PCB board, the PCB board is inside our computer or our cell phone. So PCB board in manufacture, we need to check whether there's a defect, whether there's a defect. So in this case, the expert used the CNN and transfer learning. We will discuss later transfer learning. And pre-trained model used the ImageNet dataset. And we use the ROSNet model. We will explain in the second class. ROSNet is the advanced CNN model with the 8 million parameters. So these models can identify which PCB board is okay or not good. So this is called defect detection. It is very common in manufacture and factory. Here is another example from our AIA. Our AIA students made a project for industrial safety. Because in the factory, there are some action or there are some behavior is prohibited. For example, you don't wear the helmet. It's not allowed. So in this project, our student used the CNN as a base model to do the object detection. So as you see, that first one, we can identify person. So there's the bounding box here. And we also have some label to check whether his pose is okay or not. For example, some people using the cell phone while working, or he did not wear the helmet. So we can detect the different behavior and give different warning. So this example is for industrial safety. And this is another interesting project from our AIA student. In Taiwan, there are some illegal action from the truck. The truck is trying to steal our sand from water. So it is against environmental protection. So we need to catch, we need to find out who is doing such a illegal action. But you know, the river is quite in the wild side, so not much people can go there. And for this project, our student used the civilian cameras with our CNN model to do object detection. So they can check, they can have a alarm from the camera and from the model if there's a truck going to the riverside, and the truck has some machine there, has some machine for stealing the sand. So the AI system will warn the authority, and the authority can ask police to catch them immediately. So this is another CNN application. Okay, and we'll talk about the second useful neural network called recurrent neural network. We just discussed about the vision, CNN. CNN is related to vision. Vision is the concept of spatial. It's about space. And you know, in our nature, we have another factor called time, temporal. So vision is spatial, and temporal is also important for our knowledge. So how we catch the time factor of our intelligence? Our intelligence has the time idea there. So the point is to memorize. Our brain can memorize what we learned before. So the structure of the RNN is quite simple. Just let the last time output become the input of the next time. H1t is the time equals to t output. So when we doing the calculation of t plus 1, we need the previous output of t and input to our neuron. So we have input sent as the common neural network. We have weight, and we have extra weight and extra output from previous result. So this is kind of memorized concept. And such an architecture has some problem. So there are some enhanced variant of the RNN. It is called LSTM and GRU. So if you heard LSTM and GRU later, you will know it's kind of RNN. So machine translation is a typical application of RNN. We call this the sequence-to-sequence model. This example shows the French translated to English. So French have one word, two words, three words. We just input to our model one by one. There's a time factor there. Early is cure, and later est, and later body, and later tell. So this input one by one, and then the model will output one by one. So there are some time factor in this model. The model can learn the relationship between previous word and next word. So the output is how tall are you? So how is output and input as the input of next output, and then tall as the output as the next input. So they will input one by one. So this is the operation of RNN, and machine translation is the typical example. And speech recognition is also an example of recurrent neural network, because the speech, the talk, or the word we say is time sequence. So we going through the time, we have different word. So based on this acoustic input, the voice input, we can translate or we can recognize which word we are talking about. So in this case, their acoustic input and the output is how cold is it outside. So this is another RN application, speech recognition. And this is Gmail function. Maybe you already used that. You have used this Gmail function. It's called Smart Compose. You just type maybe one or two character, and the Gmail can predict the whole sentences. So this is another use of RNN. Okay, let's talk about the third neural network model. It's quite different from previous two. It is called generative adversary network. In briefly, we call it GAN, G-A-N. The generative adversarial means that they fight each other. So in GAN model, there are two networks. One is called generated network. The other is called discriminator network. We can use the painting. We can use the painting as an example. The painting, for example, the Van Gogh has a series of painting about sunflowers. So the generated network is just kind of folders. He can fold Van Gogh painting of sunflowers. And discriminant network is kind of the expert which can examine your painting is forged or is true. So these two neural network, how to operate, let us to see. The step one is we train the capability of the examination. So this network, it have two input. One input is the real image and the other input is fake image. As we mentioned before, supervised learning, you have answer. So for this discriminator network, he have two answer, real and fake. So he can train the model to discriminate or to examine which image is real, which image is fake. So this is step one. And when the examination expert has a good capability of examination, we train the generating network. We train the capability of forge. So the discriminator fixed, and we let the forge to generate fake image and let exam expert to identify it is okay or not. So train and train and train. The forge expert can train a very similar paintings and to defeat the discriminating network. So this is how GAN work. So there are two networks fighting each other. And finally, the forge expert can generate a very real image. So it can generate the real image. It can generate the image almost like the real. So this is the typical example of GAN. We call it style transfer. So you can transfer the Monet painting to photo. Also, you can transfer the photo to Monet's painting. And you also can transfer zebra and horse. If you if you have a generated network we just mentioned, if the generating network can catch the feature or the detail of zebra and horse, you can easily to to transfer the zebra to horse or the horse to zebra because the generated network already get the detail of the image. This is another example of season exchange, summer to winter, winter to summer. And this is another example. You have a real photo and you can change to the style of Monet, style of Van Gogh, style of Cezanne, or style of ukiyo-e, Japanese painting. And here is another interesting example of GAN. We call the face generation. In the source B just kind of the base of the face, and source A is kind of style. So as you see, the the above four picture have four style. The first style is the man with the glasses, and the second one is the style of woman, and third is style of the children, and the fourth is the style of woman as well. So combine these two pictures, we can generate a face with source B and style A. So as you see this result, they have glasses, and this has a woman's face with long hair, and this has a children's face, and this is more marvelous because this woman have a small eye, so the result is also the small eyes. So this is the GAN use, and there are more applications. This application is called super resolution. It can enhance the resolution to higher degree. For example, we just input a image with blur, and we can use super resolution to gain the higher quality of the image. And this is more amazing. If your input is mosaic, and the result can generate more detail of the human face. So this example is use the ground truth to have a mosaic 8 by 8 result, and use the result to use the super resolution to come back to 32 by 32. The 32 by 32 result is more perfect than the ground truth. It's quite amazing. So this technology is also used in some camera firmware or camera software to get the better image quality. And this is another application of neural network. It's called the auto coloring. So we have a black and white painting, and use the model. It can have a coloring with very suitable, very proper colors in that painting. So you can, if you're interested, you can go to that website. And it is another application with color. It's called the colorization. If you give the model a black and white image, it can come out a vivid colored like in the real world. So it is very amazing. And you can also to colorize the previous legacy photos. For example, this is Elvis Presley. This is Marilyn Monroe. At that time, there is no color camera. So we can use that technology to come out the vivid color like we used the color camera to take a picture. This is another example called the sentence generation. It is related to the technology of the NLP. NLP stands for natural language processing. So the models can input, we can input a sentence, several sentences to that model, and the model can complete a full paragraph. For example, this input is a train was stolen in some place today, and the model can create some sentences very related to the word, the sentence that you input, and have some context there. So you can use this to generate sentences. And the model is used with the transformer. Transformer is the NLP model. And if you are interested, you can go to the website to try by yourself. And the next example is about the legal. This is the AI startup. They are trained a model which can review document. So they host a challenge that AI and 20 lawyers compete to review 5 NDA, non-disclosure agreement. It's a legal document. And the result is that the performance of AI reached to 94% accuracy, which means that they just missed the risk only 6%. And for the lawyer, for these 20 experienced lawyers, their accuracy just 85%. If you think the 85% is not far from 94%, but as you see the time, we will discuss later about the AI performance. AI, how to measure the AI models. The one is the performance. Accuracy is one index. And another factor to measure the AI model is the time. So in this contest, in this challenge, the AI just spent 26 seconds to reach the 94% accuracy. But the lawyers, they spend 92 minutes in average. So as you see, the unit is different. Even the best lawyers, he also spent 51 minutes. So the speed, the performance is outperform the human lawyer, the human behavior. So it is very amazing result. So our takeaway of deep learning. Neural network, we introduce neural network from inference and training. And we explain why deep learning booming this year. There are 4 reasons. Theory ready, hardware capability, data ready, and software tools community open source. Then we introduced 3 variants of neural network. CNN, it deals with the image related problem, and RNN, it deals with the time sequence or text-related problem. And GAN is used to generate the very real object. And we introduced more application. Okay, let's take a break. Welcome back. In previous session, we just briefed the theory of neural networks and their applications. In this session, we will talk about the status quo of AI and explore the future of AI and how to work with AI. First, we talk about the limitation. We have learned supervised learning, we have learned reinforcement learning. Supervised learning need many samples, which means you have a lot of data and you can training. And reinforcement learning needs many trials. The reinforcement learning need many tries so that the model can learn the experience from human. So these are the limitations of our machine learning. And at last, the machine don't have common sense. So talk about the common sense. That us look back of the definition of weak AI and strong AI. Maybe you remember, weak AI means the AI can do some specific task, and for strong AI, the AI can do a general task. But for such definition, some people did not agree. Just like this person, John Sears, he's a famous philosopher. He thinks the strong AI is not just an AI do general task. He raised a interesting thought experiment for philosopher. The experiment calls Chinese room, just like the left picture. There's a room, no other contact to outside, just two tunnel in and out. And the person in that Chinese room, he does not know Chinese at all, but he have a, you can say it's a dictionary, or you can say he has a very, very powerful encyclopedia of Chinese. So the people outside just threw a message in the paper in this room. And these people just use or just look up the encyclopedia to check the question and use that encyclopedia and write the answers and throw out to another person. So if we treated this room a black box, the people outside may think the person in that room is Chinese. He knows Chinese very well, but actually it's not. So John Sears used this thought experiment to against the previous definition of strong AI. He thinks the strong AI is that AI can think and AI has conscious. It's not just follow an encyclopedia to do the reaction. So this is the further definition of strong AI and weak AI. So it's kind of limitation of current AI development. This is another example of current AI limitation. It is the Chinese translate to English. Maybe you did not read the Chinese character, but if you just check the result of translation to English in the right side, maybe you feel the strange of the sentences. For example, I'm eating a restaurant. It's very strange because restaurant is not a food, it's not a vegetable. The restaurant cannot be eat. So back to the Chinese. The translation is just translated character by character. So the result is very strange. Back to the Chinese original meaning, there's some conversation like this. The first sentence may be come from your mother. The mother asks you, do you want dinner at home or outside? And you answered, I want to go to that restaurant. So the actual meaning is I want to dinner outside. But from the literally, Chinese literally, the translators cannot catch the point, cannot catch the point. So come out such a strange result. And the second one, that white car is a black car. Yeah, it's a quite strange sentence. White and black. Why why the sentence say white color and black color? So this is another Chinese meaning. So the white in Chinese means actually color. Yes, it's a white color. But the black is a metaphor in Chinese. It means illegal. So the proper translation of the Chinese is that white car is illegal. That white car has no driving license. That white car has no taxi license. So this is the limitation we show in Google Translation. This is another interesting conversation between husband and wife. The husband asks his wife, his friend invite him to pub tonight and drink. So he asks his wife whether he can come home late. His wife replied him, no problem at all. This is okay. But as you know that sometimes the wife did not reply precisely or explicitly. He replied implicitly. So we cannot read the meaning literally. If you follow the meaning literally, maybe your wife will be angry when you get home. So this is another interesting or challenging situation to AI. And this diagram shows some 4 quadrants with 2 axes about the machine learning is good at or bad at problem. The vertical axis shows the context dependent or independent. And the x-axis shows the data is more, sample is more, or data is less. From the x-axis, from the y-axis, context, intuitively, if the context is dependent for AI or for computer, for machine, it is quite difficult because it has the dependency from what happened now and what happened previously. And if the situation is context irrelevant, it's quite easy to AI or for machine learning to handle. So let us check the problem for the context irrelevant. For the sample more, I think it is quite easy for machine learning because you have more samples and the situation is not context dependent. For example, people counting. People counting means that you can use your video or use your surveillance camera to count how many people in one thing. So you have a lot of sample you can training, and it has no previous situation. You just care about what happened now. So this is the people counting, and it is good for machine learning to resolve. And defect detection, we just raised the example. We just mentioned the example before. It is also the same situation. You have a lot of example, and you don't have a context dependent. And another quadrant is sample less. For example, fraud detection. Fraud detection. Fraud detection means that your transaction may be a fraud from some bad guys. But such a situation is not as much, it's not much, so much, it's not so much. So the sample is not so much. But from AI, we can have some skill, can augment such situation, and we can have some skill to balance the fraud and the normal case. So it is also good for machine learning to resolve. This example, fraud detection, defect detection, and people counting. What we discussed is all about context irrelevant. It don't have some dependency to previous what happened. Let's see the problem of context dependent. For the sample more, for example, the chatbot. Chatbot, we can have a lot of example to train our model, but it is highly context dependent because the conversations between you and chatbot is different from, is quite different for every case. So for machine learning, it is possible to resolve, but it is not as good as those problems in the context independent. And if the context depend problem with less samples, it's almost incapable for machine learning to resolve. For example, how to predict a startup revenue. The sample, maybe you can collect some of them, but it is highly context dependent. You don't know their product, you don't know their market, you don't know their teams. So it's hard to predict a startup performance. And further case is about economy, disaster, or even worse. This case is with less samples and highly context dependent. So it is very hard to use machine learning to predict. So it is the limitation for machine learning. Next, we'll talk about the challenge. The challenge of AI to our society. This 6 points was raised by Kai-Fu Lee. He is the famous computer scientist and AI expert in China. There are 6 challenges he thinks that AI may have. The first one is privacy. So if you provide your data and the model may reveal your information. So this is a privacy concern. And security. Security concern of AI is that AI may not handle every case. For example, self-driving car. There was a notable accident of Tesla. Is the Tesla self-driving just hit a trunk because the trunk with the white plate that the Tesla self-driving did not learn before. So it is the very a very serious result of the accident because the driver is dead. So security is the quite challenge of AI. And the third one is the prejudice from data. It is quite unique to AI because the data is the base of your training, is the base of what AI learn. Uh, example is the medical information. If you just use the medical record from the wealthy person, then the model just learn the body status, the health status from the wealthy person, which means the model cannot be applied to the poor people. So it is clearly prejudice from data. So it is the challenge to AI. So we have some hot topic for AI is federated learning. It's trying to resolve such a problem. And the fourth challenge the Kai-Fu raised is the monopoly of the big company. For example, Google, Facebook, because this company is the company has many data from their customer every day. So data is the core, is the basis of AI, of the machine learning. So they can have a lot of advantage from their data. So it is the monopoly of the big company. And the fifth challenge Kai-Fu mentioned is about wealth inequality. And the last one is the job will be replaced by AI. So these two challenge, I think, is not just for AI. For any new technology, there are such a challenge. So these six challenges to our society, we need to face and we need to take care very much. And this is another popular problem for AI developer. It is called adversarial patches. What is adversarial patch? Adversarial, we discussed before, is about attack. So adversarial patches is kind of a skill to attack current object detection technology. So in this picture, you see the left guys was recognized by object detection algorithm. So there's the bounding box here. But the right guy are not identified by object detection model. Why? Because he used the patch in his body. With this patch, the algorithm of object detection just ignore him as a person. So if we want to surveillance the people coming in, this person is invisible to the object detection model. So it is a serious outcome for security. So this is a hot topic right now, is how object detection model to detect the person with such attack, with such a patch. And another famous technology in AI is called deepfake. Its core technology is what we discussed about the GAN GAN. So use that technology, the human face can be replaced with another one, or even making a video. So this is the Barack Obama face and with another celebrity speaking. And this one is the Hillary Clinton's head with Donald Trump's face. So combined together to create a fake speaking. And this is more serious one is the Mark Zuckerberg's speak never happened sentences. Just use that deepfake technology. And this is a funny case to use deepfake. Just put Mr. Bean's face in the Donald Trump's head. And this is fake news. Previous example is the image or the video. And we can use the deepfake for the text generation. We just show this example before. So you can input a sentence and then the fake news generator can generate a lot of things. It seems related to the original paragraph, but actually all the information in the generated paragraph are fake. So this is fake news. And this is another type of deepfake on voice. So we talk about image, we talk about text, and this case is about the signal, a voice. And this is really happened in the United States. CFO, some criminals use the deepfake, voice deepfake, to mimic CFO of one company and call CEO of that company, say he needs some money, and that CEO believed the voice it come from their CFO, so transfer 243,000 US dollars. So this is the actual criminal happened before. And this is a higher topic about AI challenge. It's about ethics and ethics. In the left picture, it shows the famous thought experiment called trolley problem. You are the operator, and a train is out of control. There are two tracks. One track is one person lying down, and the other track is 5 person lying down on the track. So you want to save one person and sacrifice the other 5 person, or sacrifice the other 5 person to save the one person. So this is the ethics problem and psychological problem. So this case also happened in AI. If the self-driving car uses the AI algorithm and the car brake is broken, in the front of the car have two elderly citizens and two children. Which one you want to sacrifice and save the other? So this is the tough decision for AI to make, even for person. So this is the another challenge to AI. So the impact of AI is so wide and so deep. We just talk about part of them, and here shows the others. For example, education, jobless, mortality, and privacy security, which is discussed about, and lifelong learning, or the adversary to top managers, and how to overcome the barrier of AI, even how we supervise our government for education, project management, and other construction things, and even laws and regulation we need to consider. For example, medical, self-driving, and equality issue, and even globalization of AI, even startup or inside any industry. So what is the future of AI? Maybe you have seen this robot called Sophia. He is famous this year because he have some behavior can mimic what humans do. So this is our future, and this is another famous debate between two celebrities. One is Elon Musk. He is the pessimistic about the AI. So he just conversation with Mark Zuckerberg. He said Mark Zuckerberg's understanding is limited about AI, but Mark replied to him, Mark is the optimistic about AI. So he said the Elon Musk is drum up the doomsday scenario, which means that the AI could crash our human society. So he think such a theory, such a comment is pretty irresponsible. So the debate is continuing. But for me, I think we just focus on weak AI and utilize as a tool as possible as we can. So AI is a tool. We need to use it well and to bring our benefit as much as possible. Okay, so let's move to last topic, how to co-work with AI. Let's recap the AI evolution. So I think the point is the second wave of AI. Why fair? Because there are too many things we cannot write down as rules or even codes. So this is the major problem that why we need use the machine learning and we can have such a success till now. Let's go back to Industrial Revolution. We have been through, human have been through 3 waves of Industrial Revolution. Some people say we are in the 4th Industrial Revolution. But from my point of view, I think the 4th Industrial Revolution is ongoing. We did not know what exactly happened. But let us look back to the previous 3 Industrial Revolution. For the first and second revolution, human invented machine. Before this revolution, we use our own labors to do many things. But after Industrial Revolution, we have machine, and machine can operate regularly. replace our human labor. So I mark red these two words operate regularly. This is very important to our human. And third industrial revolution is also called digital revolution. In contrast to the first and two wave, human invented machine. In digital revolution, human invented computers. And computers operate by software of fixed rule. So compare with previous industry revolution, computer compared to machine, computer can operate different based on software, but machine operate based on its own design. But for these two invention, machine and computer, both based on fixed rule. So for machine, it can operate regularly. For example, if you buy a electrical fan, the fan operate left to right, right to left, but it cannot operate up to down, down to up, because it's designed to operate like that way. So it is fixed. For software in computer, it is the same. It's fixed rule. So these rules are provided by our human, no matter machine or computer. But in current, maybe we call this is fourth industrial revolution. But I think right now is AI era. AI, the rules of machine is gained by learning based on the data we provided. So it's quite different from the previous three industrial revolution. Previous three industrial revolution, we just follow our own rule. So it is rule based, and right now it's data driven, and the rule is human to provide. And right now in AI era, human just provide data, no need to provide rule. So I think the most important summary to you today is rule-based versus data-driven. In AI, data is most important. Okay, let's check about the flow of AI project. We talked this before. AI, machine learning have three floor. The first is problem. The second is data. The third is model. So for real AI project, it's almost the same. The first step is to identify problem. The second is to collect data and do some pre-process. And third, create model and train. And fourth, we did not mention before, because this is the more real case. We need to consider verification. We need to consider patent. We need to consider the government regulation and law. And if these things has been handled, then we can deploy our AI model to the real environment. This is perfect case, 5 stage. But in reality, you will find you spend a lot of time in data. No matter collecting data, cleaning data, or process data. So the reality comes to perfect loop is we need to collect data, train, and back and forth to create a best model, and then go to verification, patent regulation, and then deploy your model. So for a house, if you want to buy
Okay, hi everyone. Since uh, will have today's synchronous session, uh, so I just I need to break the asynchronous video. So you can check the video later through the uh, Moodle or in the Teams. So maybe you can check the videos later. So we will have another session to begin to start. Okay. So I just switch uh, the session to the other synchronous course. So maybe you can we have a 3 minutes break. OK，还是要直接开始？这样不样？We have 3 minutes break. Then we will start another session. OK，路太长了。
In this part, you can
Our audio has problem. Our audio has problem now. We are handling. Please take a break and wait for us and check your attendance.
Hello, welcome back to Artificial Intelligence Winter Program. This is the second part of my course. The topic is about data science with pandas and other packages and libraries, such as NumPy, SciPy, Matplotlib, and so on. In this part, you can learn about a lot of packages and libraries used in Python, and these are useful and common use packages and libraries. These packages can help us to shorten our programming time to complete our program. And of course, if you think you are very strong in Python programming, you can write the functions and all models by yourself and do not use the packages. However, if you do this action, you will meet many issues and problems that are solved in packages. So you can think about you want to use the package or write all program by yourself. Okay. And this is my course outline introduced before. Yesterday, we see the Anaconda Colab and the Python, and today we will see the data science with Pandas and the other libraries. And let me briefly explain the package used in today. NumPy is suitable for deal with matrix computation. SciPy is created for mathematics and science computation. As for drawing some picture, you can use Matplotlib to draw and modify the pictures. And Pandas, it is used for deal with a lot of data, especially the data in table or in some field. And the scikit-learn is the very large package, and it includes a lot of function and module in it. You can use it in the machine learning and some deep learning and useful cases. Then we will introduce them one by one and make some practice for you and let you know how to use these packages and use their prepared functions, module, and algorithms to do the things you want. Okay, let's start. We will see NumPy. It is the support for large multi-dimensional area and matrix. That means if you want to use a matrix or areas to do something, you can use NumPy to help you to make your work easily. And NumPy is the foundation of SciPy, Matplotlib, Pandas, and so on. So if you want to use other package or library, you must have to know how to use NumPy. And first, if you want to use NumPy, you need to write a command like import NumPy as MP. Import NumPy, that means you tell Python you want to use NumPy. As MP means use the short word or shortened word to present NumPy, and you will not need to type NumPy. And then we will see some commands and example. Here, this is a NumPy's commands. First, you need to import NumPy as MP, and then you can use NumPy's function. This one, mp.array, means you want to build array by yourself. And this is one dimension. You can put a list 1, 2, 3, 4, 5 to make a one dimension area array. And then you will get the output. It will show this is array, and the content of this array is 1, 2, 3, 4, 5. Of course, you can define the type For example, if you input the parameters like D type equal float, and NumPy will know you want to make this element to